Okay, 3.3. So the rest of this unit is basically going to be about proving triangles are congruent. Now, so far, we've talked about the fact that if three sides of one triangle have a matching pair in another triangle that they are the exact same as, those three triangles are identical because they have all three the same sides. However, in the real world and in construction, especially, there's some times where we need to figure out if two triangles are the same as we're building, and we don't want to have to measure all three sides. So we can actually only measure a few things and know for certain that these two triangles are identical. I know my build is good and I can keep going from there. So this is, again, things that you might not use in the real world, but that are used by other people in their jobs every day. So let's talk through this. We have what are called our triangle congruence theorems or postulates. We kind of go back and forth here. So if you ever hear me say triangle congruence postulates, we have 5. So these things here are going to be our best friends: SSS, SAS, ASA, AAS, and HL. You might be like, what are those? What are those letters for? Let's talk about that. So what we're going to kind of do here is we're going to go through each postulate, and we're going to write down how we know it's this certain postulate. So what's going to happen in these problems is you're going to see a picture with things marked. Sometimes not everything marked that could be marked, and we'll get to that in class. But our first postulate is side, 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 which says if we have three sides of one triangle congruent to three sides of the second triangle, the two triangles are the same. We've done this already, right? We've already said, hey, these two triangles are the same because I've got a matching pair, a matching pair, a matching pair. Now, the reason why we call this side, 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 you only need to look off one triangle. This is a side marking, this is a side marking, this is a side marking. Please draw that on your notes. Therefore, we call this side, 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 or SSS. If I have 3 pairs just like that, that's side, side, side. So again, you only look off one triangle when you're trying to determine which postulate it is. So the question will be, what postulate tells us these triangles are congruent? If that was the picture, our answer would be SSS. So looking at the next one, this is side, angle, side, SAS. Now, notice this is how we know this is SAS. It goes in order. So this marking here is a side marking, right? We use that dash to mark a side. So I'm going to say S for a side. This marking is an angle marking. So I'm going to put A for angle, right? This marking is a side marking. So I'm going to put an S there. Again, we only look off one triangle. You don't need to scribble that one out, but we're only looking off one triangle to determine what it is. So again, this is not all 3 sides. However, this is actually true. If I have 2 sides with an angle in between them, mark congruent, matching between 2 triangles, they are actually congruent as well. So this is SAS. Going to make a note here that this is not SSA or ASS because of the ordering of the sides. You guys got your permission slips? Awesome. Come on. You gotta find it first. Okay, take a second. Do you already have yours, or do you have both? Okay. Awesome. Thank you. Sweet. You're all set. Okay. Okay, so again, it matters the order of these things. Notice how the angle is in between the sides. That's why it's SAS and not SSA or ASS. These do not work. Bad words do not exist in geometry like this. But we'll talk more about that in class. So this is specifically SAS because the A is sandwiched between the sides. Going on to the next one. So this one is angle, side, angle. So what this tells us is, again, if I know this to be true, if I have two angles matching and one side, right? Specifically, again, the side needs to be sandwiched between the angles, then these two triangles are actually going to be the exact same. Again, we don't need to know all three sides are congruent because this will actually be enough information. So once again, how we determine what this postulate is. I don't look at one triangle. I only look at one triangle. And then I go, this is an angle marking. I'm going to put an A. This is a side marking. I'm going to put an S. And this is an angle marking. I'm going to put an A. So notice the order of these. This goes, if I read from right to left, this goes A, S, A. That's because the side is in between the angles. Here are my angles. There's the side. We call that ASA. So I want you to try on this one. This one, it goes AAS. So it's basically the same concept. The difference is the side is not sandwiched between the angles. So go ahead and look at only one triangle. Label the markings. So if it's an angle marking, put an A. If it's a side marking, put an S. Just like we did on these ones, right? Do the same thing here. Okay, well, this is an angle marking because it's a curved, right? This is an angle marking, and this is a side marking. So we call this one angle, angle, side. If I'm going all the way around, right? Angle, angle, side. Or SAA, right? We could go SAA. This is not angle, side, angle, though, because the side is not sandwiched here in between. It's on the outside. So that there is a difference between these two, right? It's where the side is. So angle, angle, side, AAS. Okay, this last one now is different than the rest. This last one is called hypotenuse leg. That's HL for hypotenuse leg. So what we need here is we need the hypotenuse specifically marked. Now, looking here in one triangle, once again, we're going to kind of ignore one for right now. Looking in this triangle, can you tell me which side is the hypotenuse? We've got AC, BC, AB. Which side is the hypotenuse? Well, the hypotenuse, this is review, is always across from the right angle. So here's my right angle. That's the hypotenuse. I specifically need the hypotenuse marked to be able to use this theorem. And we only have hypotenuses in right triangles. Hypotenuses don't exist in any other triangle. So it has to be a right triangle, and I have to have the hypotenuse marked, as well as one other side. So this is the L that we're talking about, a leg, right? Hypotenuse is special. It's across from the right angle, and then we have a leg. So that makes this HL. Because it's a right triangle, this only works for right triangles. So what we're going to do is we're going to practice these in class. I just wanted to kind of talk through them and talk about how we know based on the markings which one it is. Again, this will be a very good trick for you. If you go, hey, this was an angle, angle, and a side. This was a side, a side, a side. That's how we know which postulate to use. We'll practice this more in class.